Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine you're standing in a factory at 2 a.m., a machine starts vibrating, temperature spikes, alarms blink. An AI flags an anomaly, but here's the real question. Can it actually explain what went wrong and suggest how to fix it? Today's story is about a paper titled SenTSR-Bench, Thinking with Injected Knowledge for Time Series Reasoning by Zelin He and Boran Han and their collaborators. And it's about teaching AI not just to detect problems, but to reason about them. The authors identify a clear gap. On one side, we have powerful general reasoning LLMs. They think deeply, but they don't truly understand complex time series patterns like vibration drift or multisensor anomalies. On the other side, we have specialized time series LLMs. They recognize patterns well, but they overfit. Their reasoning is shallow. They struggle outside narrow templates. So, in real world diagnostics, root cause analysis, multi-stage troubleshooting both fail in different ways. It's like having one expert who can analyze logic and another who can read signals, but they never talk to each other. The core idea is elegant knowledge injection. Instead of merging models or fine tuning a giant one, they let a specialist model generate grounded time series insights first. Then, and this is key, they inject that knowledge directly into the reasoning trace of a frozen general LLM, not as a prompt, but inside its thinking phase. The reasoning process is explicitly split. First, the model generates a hidden trace, then it produces the final answer. The specialist's analysis gets prefixed into that segment. So the general model continues reasoning, but now grounded in domain knowledge. Even more interesting, they train the specialist using reinforcement learning with verifiable rewards. No human labeled reasoning traces. They reward two things: correct format and correct answer. This forces the specialist to learn analysis first thinking automatically. To test this idea, they introduced SenTSR-Bench, a real world multi stage diagnostic benchmark built from industrial sensor streams. The tasks go beyond anomaly detection. What happened? How did it happen? What's the fix? Unlike synthetic datasets, these are human verified diagnostic annotations from real breakdown events. The evaluation includes 110 real multivariate sensor streams and 330 multiple choice diagnostic questions. And they even generate 6,000 synthetic training examples using vision language models to diversify training data. This isn't toy data, it mirrors real maintenance reasoning. The results are strong. Across SenTSR-Bench and public datasets, injection improves over standalone specialists by up to 26% and over general reasoners by over 22%. RL-based injection consistently beats supervised fine-tuned injection. They also compare injection against prompting methods like few-shot, self-consistency, and tree of thought. Injection wins. Why? Because prompting hands knowledge outside the reasoning trace. Injection embeds knowledge inside the reasoning trajectory. That difference matters. Early injection, right after the thinking token, performs best. Mid or late injection can cause drift because the specialist isn't trained to critique long reasoning traces. Now, let's talk pitfalls. If the general model relies only on the specialist summary without direct access to raw time series, performance drops significantly. That creates an information bottleneck. Best practice: give both models access to the raw data. Let the general reasoner verify the injected knowledge. Another insight: increasing synthetic diversity helps early but saturates after about 75%. So, more data isn't always the solution. This paper shows something powerful. We don't always need bigger models. Sometimes we just need better collaboration between them. Knowledge injection might be a blueprint, not just for time series reasoning, but for domain aware AI systems everywhere. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.